So, hey guys, today we'll be discussing a very good lead code question, and the question is called Find the First Missing Positive. So, usually I do not make videos unless and until necessary. I felt like there are a lot of less solutions on the YouTube which actually focuses on a very intuitive solution. And I felt that it's a perfect time for me to produce my own video and try to explain it to you guys. But there is a second set of reason also. The problem over this question is that you can eventually solve it some time complexity with some space complexity, but the question says that we have certain constraint. But this is not the only problem. The problem is that these questions are pretty much frequently asked during the interview, and the interviewer will have a certain fixed algorithm. Let's say that he has only studied this algorithm, he has marked it up, and he has only for certain fixed set solution in his mind. The problem is that any solution which you give in other format is going to be a very brutal for you. I'll be honest, because that will just decrease your chances to get selected. And the interview will be like, hey, this guy might not have gone through the solution section and he might just have implemented its own base solution, right? So let's not do that, and let's see how we can intuitively solve this given question. So let's try to understand that we are given an unsorted integer array and we need to return the smallest positive integer that is not present in nums. So we need to implement the algorithm in O of n time complexity and with the space of O of 1, right? Let's see that given example. Now in this given example, we have the elements like 1, 2, and 0. So we know that all these elements, right? We want to find the first positive one. I mean, obviously we can't pick 0, right? 0 is not a positive one. But now let's see that key all the elements 0, 1, 2 are present. So what is missing over here? 3. So we return 3 over here. Similar thing will happen over here. When we start iterating, let's say that we start counting from 1, we find 1. But let's say that we found 2. No, 2 does not exist. So that means 2 is the first missing positive integer. Similarly here the problem is that we are given an array which starts from 7 and it ends till 12. And the thing over here is that 1 is not given. So this becomes the first positive integer that is missing over here. So these examples are pretty intuitive because they give you a full idea about how you can construct a solution. So let's see what is the given thing. Now, what I'm going to present over here is that, see, the larger box, let's consider that the larger box is some array. Like larger box is some array. And there are three different cases which can happen over here, right? I mean, permutation combination of three different cases. So let's try to understand what can eventually happen. Let's say that we were given that we were having an array which only selected all the negative elements, right? It selected all the negative elements. So what would happen if all the elements were negative? What would be the first missing number? That would be, let's say that that would be 1, right? Because I'm saying there are only negative elements and there are no positive elements which is provided to you. So obviously the answer becomes the first missing number, that is 1. Now, I'm not going to directly jump to this. Let's say that if I draw a bar over here and I'm given n plus 2 z, z is something in not infinite but some till some point. But we know at this point what will the first missing number? 1, because in this section the entire thing 1 is not present over here, right? Now let's take it further. Let's take it further by including 1 to n. Now this is where the complexity lies, and this is why the answer to this solution is very intuitive because of 1 to n. So what can eventually happen is that in this 1 to n there can be different numbers, like there can be numbers which might have 1, which might not have 1. So I'll just try to erase this, see what can be the different kind of solution which are eventually possible. So let's say that 1 is present in the first case, 2 is present, and let's say 3 and 4 is not present, right? Let's say that 3 is not present, let's say that 4 is present. Now when we play with this entire thing, let's say that now we include the entire negative elements along with 1 to n, some 1 to n elements. We know that 3 is missing over here, so 3 becomes a first missing number. Similarly, if I move my window something over here, now from this point I know that again 3 becomes my missing number. So this is giving me a hint that I only need to care about the numbers which are in the range of 1 to n. I only need to care about the numbers which are in the range of 1 to n. Because note, having the negative numbers or having great numbers greater than n plus 1 does not affect my solution. It does not affect my solution, right? So that's why only in the range of 1 to n, I am only worried about that part. So I'm not worrying about 0, dude. I'm not writing 0. Let's just forget Aryabhatta for a second. So apparently, what is gonna happen is that Now let's see how we can construct a solution based on this. What if we can place, see, now we, the problem is that the entire array is in a jumbled format, right? And I'm saying you that I only want to care about the elements which are in the range of 1 to n. So let's draw a new array which is in the range of 1 to n, and let's express it via this. Now what might happen over here is that there might be lot elements like this: 4, 1, 2, and 3. And all of this are in a jumbled format. All of this are in a jumbled format. And for our given sake, let's say that we gayab one number. Let's say we vanish the number 2, and let's put just a arbitrary x. Let's say that we have just deleted 2. So we now, the only problem now remains is that, the new problem which I'm telling you over that we need to find a number from this jumbled array such that it gives me the first missing number, right? It gives me the first missing number, and how we can eventually do that. So note one thing, guys, note one thing. I do not care about the other noises over here, right? We will be given the negative elements, we will be giving elements ranging from n plus 1 to c. I do not care about that, right? What if I can eventually place all these numbers to their respective indexes? What if I can eventually place all the number to their respective indexes and just say that the first number which is out of their index is the missing number? What if I can do that? Let's see how we can eventually achieve that. So note that negative numbers can be present anywhere, n plus number can be present anywhere. I do not bother about it because they are not going to give me the final answer. I'm only bothered about the 1 to n wala phase. So eventually that is eventually I'm going to do. है ना? Because let's say that 1 to n. Now you might ask me, I had just explained you from, if the numbers are if 1 to n numbers are not present, that means 1 to n numbers are not present and it's all n plus 1 greater. That means the 1 becomes our smallest number, right? So it's all, the answer is always relying on the fact that this will be in the range of 1 to n itself, right? And let's see, okay, how we can eventually solve this given question. Now, what might happen is that 1, 4, 1, 3 is present. And what I'm saying over here is that what if we try to put all of these numbers in their respective positions? We can do that, right? We can, the way we are going to put it here is that we can put 1 at the index of 0, right? We just need to take care of the indexing thing. That's all, guys. We just need to take care of the indexing thing. So what I'm going to propose over here is that 1 will be put over here, right? So since there are no elements in the 2 might have some any arbitrary value. Let's say z. Okay, this almost looks like a 2. So let's say x. I'll put x over here, right? X can be any value. X can be negative. X can be, let's say it can be negative value. It can be greater than n plus 1 value. It can be just anything, right? But it can be even a value within the 1 to n range. We do not care. But we know that it is not 2. It is some other element. It is an imposter, right? Let's make an imposter red. So there is an imposter over here. Now, when we go ahead, we are going to put all the other elements in their respective positions, right? So 2 was, let's say that some arbitrary number 2 was put in this position. Now what will happen? 3 will come over here at the index of 2, right? And okay, let me erase it because this will just this is not an index, right? This is indexing wise, it's not there. So 3, I put it over here. 4, I put it over here. And let's say for given example, now I start iterating my array and just say that, hey, all the numbers, I check that, hey, num are you equal to I plus 1? If yes, then you are good. You are not an imposter. If no, you are an, we're gonna say that you are an imposter. You are an imposter, right? We just need to do this operation. Now, the only thing is that how do we represent the array in this format? How do we put it? So try to understand, guys. Try to understand. There are few corner cases which I have not covered over here. Let's say for a given example, if 2 comma 2 comma 3 was there, let's say that this 2 comma 2 comma 3 was there, right? So the thing is that we need to do some swapping operation. That's first thing for sure, right? We can do a swapping operation. Like let's not even take this example. Let's take the example, a very basic example, like 3 1 2, 3 1 and 2. Okay, now just try to understand over here one thing. Let's say that I want to put 3 to its respective position. I want to put 3 to its respective position. And I say that, hey, whoever was at 3 minus 1 index, then index, okay, what will be the rightful index for 3? It will be 3 minus 1 because I need to take care of the indexing as well. And the 3 needs to go at the index of 2. So what I can do is that I can perform a swap operation. I can perform a swap operation with these index, with the current index. Let's say that this was the current index and this new index. I can perform a swap operation with this current index and the new index. And let's say that I did perform a swap. What will happen is that 2 will come over here. 2 will come over here, 1 will come over here, 3 will come over here. Now note guys, note one thing. If I were to move my current over here, then one thing I am not ensured is what? This 2 becomes out of position. This 2 becomes out of position. So you get one new problem, right? So first I will iterate what we were doing. We know that we were caring about 1 to n numbers. Now we started put all the numbers in their respective indexes. But now we encountered a problem where now putting all the numbers to their respective position, we can end up with a situation. If we just do it single time, we can end up in a situation where the new number which is introduced, it's also out of bound. So eventually what we have to do is that we need to keep running. We need to keep running this in a while loop. We need to keep running this in a while loop till the number is satisfied with this position. And that's all guys, you need to eventually do. So now again what we're gonna do is that, hey, we're gonna say that, hey, we're gonna run the while loop again, and we're gonna say, hey, our current also looks out of position, so nums of current, again our while loop will run, and again a while loop will say that, hey, nums of current is actually not equal to the new index of the nums of current, right? It will not be equal to the, sorry, this will be something like this, nums of current minus 1, right? This will not be equal to the given position, and that's why we need to do a swap operation. And again we will swap it, but now this time we will swap with what? 1. We will swap with 1. So the new number will be 1 comma 2 comma 3. The new number will be 1 comma 2 comma 3, and that's it. And we have sorted this array. Now what will happen eventually is that, guys, note, now since we will start traversing it again, so for the final answer I will just delete everything now, since it's become clear to you guys. What might happen is that over here, since let's say that we have sorted all the given elements, now what might happen is that we might need to just iterate over it, and we might find that all the given numbers are at its respective position. But what now? If all the numbers are in their respective position, that means the n plus 1 is missing. Because let's say this n is equal to 3, then obviously all the numbers till 3 indexes are present, till 3 elements are present. So now the only missing number is 4, right? And this solves our problem. And now I just want to give you one final thing. What will happen? Do you think what will happen if we select 2 comma 2 comma 3? Right? If we do a swap operation, we say that, okay, a current will be here, right? A current will be here, and we say that, hey, 2 looks very sus because it is not at its given position. But also we need to check if the number at the new position which we want to put to, it's equal to that or not, right? If this 2 it is appropriate candidate over here, then why do we need to swap it? So this gives me one hint. The new index the current index number and the new index number, they both should be different. So that I can perform a swap operation. So eventually we will not swap it, right? And we just move ahead. And once we move ahead, we will encounter that this array will be finally in this format 2 comma 2 comma 3. And now once we figure out that, hey, once we start iterating, we see that, hey, this 2 looks odd because ideally I plus 1, the element which should be present over here should be I plus 1. We will start with index I is equal to 0, right? And we will compare with the nums of I. So ideally यहाँ पे क्या होना चाहिए था? यहाँ पे होना चाहिए था 1, but I had 2. So that's how we're gonna return the 1 as a missing number over here. So using this algorithm, we are eventually taking care of few things. We are taking care of the placing all the elements to their respective position using a while loop. The second thing is that we are taking care of the duplicate as well using this algorithm. So let me type the solution for you guys. I don't know how a new browser speaks with that, but anyway. So does it zoom? No, but I can at least do this. So let's say कि इसको कोड कैसे कर सकते हैं. And I'm going to start putting all the elements to their respective positions. So I have said over here, we don't need to care about all the negative elements. So what we eventually need to care about, elements which are greater than 0 and the elements which are less than n, right? Which is less than n. And let's define the n over here as well. We have defined the n. Now, as I had said over here, we need to look at the current number. We look at the current number and we say that we compare with the appropriate index. So what do you think the current number appropriate index will be? Right? It will be nums of I minus 1, because we are taking care of the indexes as well. So what would eventually mean is that The one, okay, what this would eventually mean is ki we are infinitely looking for a number which with the proper indexing. That's all, guys. And we just need to perform a swap operation with the nums of I and nums of I minus 1. And at the end of the day, what you have to do is that you need to compare, we need to run the loop again with the n. And this time, what we are going to do is that we need to find if I plus 1 is equal to, is not equal to actually nums of I. And if it is not equal to nums of I, we know that this is the given missing number. Otherwise, we know that n is the missing number. N plus 1 becomes our missing number over here because, as I explained in the given solution. And see, okay, this works or not over here. Yep. Let's try to submit this given solution. Let's see if it works or not. Fabulous. This given problem works with this given approach and it gives me 100% result. So I hope you enjoyed the video, and this was my take on this given problem. And you notice how fast I was able to code it up because the initial understanding for me about this problem was very clear. So thank you guys. I hope you liked the video. Please share it with your friends and keep preparing for the interview. Stay strong. I know the market is tough, but you're gonna make it.